All right, welcome back to Calc, everybody. So this is still section 4.2. So now we're looking at example 5 for t between 0 and 8 seconds. A particle p moves along the x-axis. The position, velocity, and acceleration of the particle p are differentiable and modeled by the functions x sub p, v sub p, and a sub p, respectively. Selected values of x sub p, v sub p, and a sub p are shown in the table above, where x sub p of t is measured in meters. All right. So make sure you guys are highlighting important information. So again, x is the position function. Then we have our velocity, acceleration. All these numbers are between 0 and 8. It says that the function is differentiable, right? So if a function is differentiable, that means it is continuous, right? So that's one of the things that we do have to take into consideration later on. All right, so let's talk about the first problem. Is particle p moving towards or away from the origin at t equals 4? Give a reason for your answer. So in order for us to determine, first we have to know where the particle is at when t equals 4, right? So first we have to find the position, which would be x of p of 4 equals, in this case, we're looking at positive 6. All right, so I know 0 is right here, positive 6 is right there. So if the particle is moving towards the origin, that means that the particle, the velocity has to be negative, right? If it's moving away from the origin, going to the right, that means the velocity will be positive. So let's figure out what is the velocity. So p of 4 at 4, so we see it's negative 1. So we know that v of 4 is less than 0, meaning it's negative. So that means that the particle is moving to the left towards the origin. So we can say particle p is moving towards the origin. The origin, right, at t equals 4, right? Because, so x sub p of 4 is equal to positive 6, and v sub p of 4 is equal to negative 1, right? So again, it's negative, so that pretty much gives us our explanation. So now let's look at part B. Is particle P speeding up or slowing down at t equals 7? So let's see what's happening at t equals 7, right? We want to make sure that for us to be able to know whether or not it's speeding up or slowing down, that means that the velocity and acceleration are going to be either both heading in the same direction, both positive, both negative, or both will have opposite signs, right? So let's see what's going down. So let's first, v of p of 7 is equal to, looks like negative 4, right? And then a sub p of 7 is equal to negative 3. All right, so if we're at positive, so our particle is sitting at positive 7, right? The velocity is less than 0, and the acceleration is also less than 0. So that means that we're moving in the same direction. We're moving away from t equals 7, right? I don't know if t equals 7 is, well, it's in the positive side as well. So that means this one is also moving towards the origin. So, but it is going faster, right? So it is speeding up. Particle P is speeding up because both a sub t, a sub p of t and v sub p of t are negative. All right. So again, even though both of them are negative, that means that they're speeding up. If it was a positive and a negative, that means it would be slowing down. All right. So now let's look at part C. Use the data in the table to approximate the value of v sub p of 2 and the units of measure with your answer. Now here you guys have to be careful because you're not going to be using these values, right? Because again, if you're doing an approximation, that means you're looking for the slope of the secant line. And here we're given for V, that's already the slope of the tangent line at those points. So here we're looking to see where is 2. We know it's between 1 and 3, right? And then we're looking only at the position function, right? So that's pretty much what we want to look for. So V of P of 2 is approximately equal to x of p at 3 minus x of p at 1 over 3 minus 1. And that gives us 8 minus 2 over 3 minus 1. And that's equal to 6 over 3, which would be positive 3. Now, make sure you indicate the units of measure. So here, x of p is measured in meters and t is measured in seconds, I think. Let's make it seconds, even though it doesn't say. It could be hours. Yeah, it's seconds. It says right there, it's seconds. Okay, so here we're going to say, since the top number represents distance, those are the meters per second. All right. Is there a time c where c is between 1 and 7 such that v of p of t is equal to 0? Justify your answer. Now here is one of the things that you have to know, right? So how do we know it crosses the x-axis, right? Without having to look at the graph. So in this case, this is one of the theorems that you guys are already familiar with, which is called the intermediate value theorem. Since this function is differentiable, right? So differentiability implies continuity, right? Continuity does not imply differentiability. Remember that? That's one of the things that we've discussed before. So here, one of the things that you guys want to apply is the intermediate value theorem. And the intermediate value theorem is the one that guarantees that if you have a differentiable function, that means that it's continuous. That means that if you're going to get from one point to the next, that means that all the values in between those 2 points must exist, right? You don't know what exactly they are, but they exist. And that's pretty much what the intermediate value theorem tells us. So here, in order for us to determine when does that happen, we want to see when does it change sign. So we know that's 0, right? So when does it change sign? When does v of t change sign? And if you guys notice here, it changes between 3 and 4 seconds. So between 3 and 4, right? Between 3 and 4, it goes from positive to negative. So we're going to say between 3 to t equals 3 and t equals 4, there must be a t such that vp of t is equal to 0 because of the intermediate value theorem. All right. So it's that simple. So again, just make sure you want to see where it changes sign, right? And I forgot to include that part. So because of the intermediate channel, and then we can say that v of t changes sign. All right. It says for t between 5 and 8, a second particle q moves along the x-axis. The position of the particle q is modeled by x sub q of t is equal to 12 minus t minus 10 quantity squared at t equals 7. Are particles p and q moving towards or away from each other? Explain your reasoning. So again, we want to see where they're at, right? If they're in opposing, so we're going to first look for the position of both at t equals 7. So let's look for x of p 7 for the first particle, and that one happens to be at positive 5. All right, so we know that. And then let's look for x of q at 7 for the second particle, and that would be 12 minus 7 minus 10 squared. So that gives us 12 minus 3 squared. So 9 minus 9 is equal to positive 3. So by position, we know 1 is right here, right? This is particle Q. And then the other one is a positive 5, which would be positive, just P. All right. So now here we wanted to, now the next step, in order for us to determine whether they're moving towards each other or away from each other, is that if they have the same sign, right? If they have the same sign, both velocity, for velocity, that means they're going in the same direction, right? So they're not moving, they're actually going away from each other, I would say. If they have opposite signs, right? If they have opposite signs, if Q is heading towards the positive side and 5 is heading towards the negative side, then that means they're going to cross each other, right? They're heading towards each other. So let's see what happens right there. So V of P at 7 is equal to, let's see what goes on at 7, -4. And then, so that means that this one is moving to the left, right? So we can say V of P of 7 is less than 0, so it means it moves to the left. And then we want to find V of Q, V sub Q, at 7. So first we're going to find the prime, right? Remember, we have to find the derivative of this first to be able to find the velocity function. So using the chain rule, you're going to get -2 times t minus 10, all right? So we can just leave it like that, and then we would say V of Q of 7 equals -2 times 7 minus 10. We end up with -2 times -3, which is +6. So now we know that V sub Q at 7 is positive, so it means it's going towards the right side. So just by looking at this, we can conclude that both particles are going towards each other. Both particles are going towards each other. All right.